Hi and Assalamualaikum warahmatullahi wabarakatuh to my lecturer and the audience. We have been given task to present about the trigonometry, and our group has chosen the topic, and the topic is trigonometry in military engineering. First of all, let me introduce you to my group member. First member is Afilan and Sulaiman, Muhammad Hafiz bin Dalani, Yang Sultan, and Muhammad Asad. Let's move on to the introduction. Okay, what is military engineering? Military engineering is basically defined as the art, science, and practice of designing and building military works and maintaining lines of military transport and military communication. Military engineers are also responsible for logistics behind military forces. Modern military engineering differs from civil engineering. In the 20th and 21st century, military engineering also includes other engineering like mechanical engineering and electrical engineering. So let's know what is trigonometry. Trigonometry is a branch of mathematics that gives an application of length and unit. It immersed in the analytic so application of geometry in astronomical studies is the key focus on the calculation of stars, while mathematicians in India create the earliest known table of value for trigonometry ratios such as sine, cosine, and tangent. What is the use of trigonometry in military? Trigonometry used in military, the trigonometry was used in various forms. It was used when the army was to start their strategy. Military also used the trigonometry when they want to win a war, so that the approximation do not reach the enemy. The military has been using the trigonometry method World War II and continues until now. The trigonometry is also used in the Navy branch, Air Force branch, Marine branch, and research. That's all for me for the introduction. I will pass the presentation to Hafiz for the application.
Thank you, Pak Hafiz. Before we start with my part, is application of trigonometry. Let me introduce. My name is Muhammad Hafiz bin Zalani. My number registration is 01 BKM F122 from class BKM Kadudi, and my lecturer is Miss Azima. Okay, my part is application of trigonometry. The random of about the military engineering in application of trigonometry, the geometry of war. What is it, the geometry of war? During the war, mathematicians responded to the growing demands and developments of warfare by applying practical geometry as a solution to their problems. They devised techniques, designs, instruments, workbooks, and continually look to solve new issues to use geometry for gunnery and weaponry, debating and surveying, fortification and formation. The first point, we can look the road books. The geometry of war. The example we can take is like the book from Sun Tzu, like the art of war. He used the book for formation and fortification to defend our zone, for our location from the enemies. Like example, we know the Great Wall at the China. So we continue the next part. Alright. What's mean the gunnery and warranty and what's mean of gunnery and weapon system? On this we have a self-artillery propelled gun from the United States Marine Corps. This artillery called the M109 family is the most common Western indirect fire support weapon of maneuver brigades of armor and mechanized infantry divisions. Their firings works is used with trigonometry to give accurate enemy position. So the gunnery are like the self-artillery propelled gun, more conditionally in the battlefield use the trigonometry to give accurate enemy position. Like we can take the scene of the battlefield, we can take most likely use the SAPG or either called self-artillery propelled gun. Same battlefield we can look is Iraq-Iran war. So we can look they have more technology of SAPG. So the additional knowledge, the little bit additional knowledge we can take. The United States Marine Corps is a half branch of Navy and the Army of US Navy. Their responsible role is expeditionary and amphibious warfare. That US Marine Corps more to the Navy branch and half is for Army branch. Okay, let's read through the another part. And the second part is navigating and surveying. So we can look. We have a picture or example like submarine and the submarine call and the submarine of the name call. Submarine is a class, a sub-Akula class. First, navigation is a field study that focuses on the process of monitoring and controlling the movement of a craft and of vehicle from one place to other. The field of navigation includes four generally categories like land navigation, marine navigation, aeronautic navigation, and space navigation. The first point we can look more from Navy branch and the Air Force branch, because on the first point we can look Navy have the technology like the submarine have the navigation modern technology, and the Air Force branch have the monitoring tower to give more navigation our airplane. And the second point we can look surveying, mapping, and drafting. Technician help determine, describe, and record geographic areas of features. They conduct land surveys, take measurement, make maps, and prepare detailed plans, and drawings for construction project. They are also sometimes called upon to provide maps and surveys that locate military target and help plot troop movement. These technicians play key roles in the field of geospatial information. So the second point we can look is more like the army branch, half the army branch, because this point we can look the surveying, mapping, and drafting technician, because in the army branch, the army, as the army technician or as the army engineers, the army need more competent skill like record geographic areas of features and describe, determine maps like the problem we have the contour on the forest or the hill.
Hi guys, my name is Akilan, son of Rishimaran from DKM 1D. Today I would like to explain about the mathematical solution with drawings and the usage of trigonometry in geometry. By using trigonometry, we can calculate the vertical velocity and horizontal velocity which a bomb travels from one location to the targeted location. The angle will be mostly selected by the military officers where the bomb was shot and where the bomb should fallen off. By using the trigonometry, we can calculate the exact location where a bomb would fallen off and the initial velocity by using three operations from trigonometry. They are sine function, cosine function, and tangent function. The formula of these three operations are sin is equal to opposite per hypotenuse, cosine function is equal to adjacent per hypotenuse, and tangent function is equal to opposite per hypotenuse. As we can see, this diagram is used to show us the bomb trajectory, which is mean by where the exact location, the initial location of the bombing, and the final location where the gravitational potential energy of a bomb do end. There are two types of solution being used in this part, which is sine and cos. Sine solution is equals to x over hypotenuse. Normally, military officers will use this solution to find out the vertical velocity of the bomb, whereas the cos solution is used to find the horizontal velocity, which is velocity of the x-axis of the bomb. So let's see how the bombing is actually made in military by using the trigonometry formula. The angle of the bomb is 25 degrees from the land and the velocity of the bomb is 140 meters per second. If we want to find the vertical velocity, we have to use sin formula. For example, sin 25 degree is equals to x, which is vertical velocity per 140 meters per second. The answer is 59.17 meters per second. And if you want to find the horizontal velocity, we have to use cos formula. Cos 25 degree is equal to y, which is horizontal velocity, over 140 meters per second. The answer is 126.88 meters per second. In addition, calculating the distance also really important to target a location by shooting or bombing. The formula which used to calculate the distance is horizontal velocity times with the time taken. As we all know that the horizontal velocity is equal to 126.88 meters per second and the total time taken is 12.085 seconds. The product of this calculation is 1532 meters. So the distance traveled by the bomb or the bullet is 1532 meters. Despite calculating the velocity of the bullet of a bomb, total time taken for a bullet or the bomb spent in the air also matter. So the formula to calculate the time taken for the bullet or a bomb spent in the air is equal to 2 times vertical velocity per gravitational potential energy. As we all know that the gravitational potential energy is equal to 9.8 meters per second and the vertical velocity, as we calculated earlier, is 59.17 meters per second. So we have to use the formula which is 2 times by vertical velocity over gravitational potential energy. So the answer is 12.085 seconds.
Hi, I'm Simple. Now I will explain on the conclusion part. In the nutshell, we all know about the military engineering and the use of the trigonometry in the military. Mathematics is the foundation of all disciplines and is closely related to our life. The military is also a part of it, where mathematics has been known since the very days of mankind, and is also played an important role in the development of the military. As early as in ancient worlds, people used the mathematics to win the war. The continuous development of the society, mathematics and the military has used many different words to get closer and closer. For example, in the world of using the mathematical trigonometry in many theories, it is very important to give the direction and distance of enemy's position on the battlefield. Then, we can know that military mathematics is not only used in the army, it also includes the Navy, medical corps, and Air Force. They are both suitable for the best application to use. In addition, we can also learn multiplication from facility. It is observed that mathematics is one of the most useful and reliable weapons of the military. Besides that, triangle can be solved using trigonometry to determine the unknown side. In this hands-on work sessions, the idea of right triangle trigonometry is all around the utilizer in deciding the tallness of the building. We can dominate the process of the upward points utilizes the other lines. Likewise, in this hands-on work movement, we can apply the informations learned in the estimation of right triangle in deciding the tallness of a removed point. The last part is question and answer sessions. Let's do the questions. The first question is, what is two directions of motion in the case of a bomb? The answer is, the two directions of motion in the case of a bomb is horizontal and vertical. The horizontal is x-axis, the vertical is y-axis. The second question is answered by Sangkiran Anlaki Lechemanan. Thanks.
Thank you, Yong Sing Kong. And the second question is, give the formula of vertical velocity and the horizontal velocity. The formula of vertical velocity is sin theta, which is the product of sine and the angle is equal to y-axis, which is vertical velocity, divided with hypotenuse. If we want to find the vertical velocity, we have to find the product of sine theta and the hypotenuse. And the formula of horizontal velocity is cos theta, which is the product of cos and the angle is equal to the x-axis, which is known as the horizontal velocity, divided with hypotenuse. And if we want to find the horizontal velocity respectively, we have to find the product of cos theta times with hypotenuse. Thank you.